Hey, hello. You're stuck in traffic with Wolf Gorlick. Couple-minute riff on IT and IT security. Driving down the highway. So, vulnerability was out a couple days ago on TrueType fonts. So, you send in a malicious font with an umlaut, and you have the ability to create a buffer overflow. Getting a lot of vibe on the camera. Sorry for anyone who's watching this. Little known fact, umlauts, right? So TrueType fonts, things for umlauts and whatnot. You may note that Wolfgang Gorlick is spelled without an umlaut. That's because my grandfather in the 1920s, as he was coming across, Americanized our spelling, being well aware of the hidden vulnerabilities of Unicode in language processing. So even from my grandfather on, the Gorlick family has been very, very security conscious. But little known fact for you the listener. The other one that just happened, and it came out today, or was announced today, courtesy of my friend Ken White, was the GNU, however you want to pronounce it, libc vulnerability. So anything that's doing libc processing, there's a possibility of doing a particular buffer overflow in that. And neither of those are what you would consider to be traditional vulnerabilities, right? So it brings up a very important thing to consider when doing vulnerability research, and to consider and wrap your mind around when doing capture the flags or any types of protection. Every single piece of data is ultimately an input to something else and an output to something before it. And the vulnerability could be anywhere in the stack. So if you got a stack of turtles, a stack of processes, you're basically passing data in and out of different applications, all the way up and down the stack to display something, to read something, to do whatever. Most of the inputs and outputs, of course, are not even human readable anymore. Most of it is on the back end between APIs and what have you. Why this matters is that every single thing is an input and output. Every single input and output is an opportunity to introduce a vulnerability or pass through one system to get the vulnerability to another system. PHP and the vulnerabilities it had is a good example, which you would pass data in and the data would go through PHP and get to C and create the buffer overflow. Everything is data in, data out. Packets on the wire, data in, data out. Fonts, data in, data out. You name it, this is where your inputs, outputs, your vulnerabilities are going to be. Which is why fuzzing is so interesting, right? You throw lots of data at something, see what happens, fuzz it, and get the results. It's also why security can be so difficult, because oftentimes the systems we test are the systems we can see. What can we type on a keyboard to make something happen? What can we jiggle and lock to make something happen? Very rarely are we thinking about all the systems we can't see, which is the majority of the code, which is where the majority of the vulnerabilities lie. And that's where APIs are coming to play, fonts, any number of interesting things that are vulnerabilities that you wouldn't think would occur. So what do you do? If you're building code, static code analysis, dynamic code analysis, but on non-traditional inputs on the objects themselves. If you are creating code itself and you want to look at stuff to protect within the application, look up aspect-oriented programming, where you make security a cross-cutting concern. You can wrap the individual inputs and outputs at the process level or at the function level. Pretty cool stuff. Create defensible applications, following those inputs and outputs. CTFs are always interesting because it'll be something like, oh, you got this PCAP file, create a buffer overflow from it. Like, ah. So if you're doing CTFs, remember everything's inputs, outputs, manipulating the data stream. That's it. Have a good one. Cheers.